Although these days we see LTE, 4G, and very advanced devices, handheld smartphones, but at the underlying level, all these are designed on the basis of the classical modulator, demodulator, and encoder, decoder. The communication channel that comprises of transmitter and receiver consists of some basic functionality that has to be implemented in order to allow the communication which otherwise can never take place. As we have seen that frame size, minimum or maximum, variable or fixed, is a very important thing to be understood before the design can proceed further. One of the ways to look at frames is what kind of data it is carrying. Is it carrying alphanumerics or is it carrying binary data? In this module, we'll start with the character-based framing and we'll understand what these character codes are, how these can be used for communication control, what are the problems in illegal code representation, and finally, we'd look at the solution, which is called the transparent mode, through which character-based framing can be carried out for alphanumeric kind of data. The reference is Data Networks by Bertsikis and Gallagher. Here in this book, they mathematically formulate the scenarios which are basing the data representation for video, audio, alphanumerics, and so forth. The character codes, as we know, are mainly ASCII characters, which are 7-bit or extended ASCII as 8-bit in length. We also have Unicode these days. Mainly these are representing the keyboard characters and the terminal control characters. However, we see that in communication, if you have especially worked, say, with Linux or with some of the router configurations, some control characters are used as controlling functions through which the behavior of the device can be managed. For instance, there is a control character called syn or synchronous. The primary usage of syn or synchronous idle is it provides a filler between frames when the data link control on the sending side has no data to be sent, but the receiver is afraid that it will go out of sync. So it needs continuously transmitting sync characters. So these sync characters are used as fillers for the gap. Then we have start of text and end of text, which are used as communication control characters to mark the start and end of a frame. This is also called delimiting. So if you were to imagine data which is alphanumeric or character based in nature being sent between sender and destination, it would have the form like this. We see here that we have the syn as fillers for the gap. Then we have start of text, the header itself, which might include source address, destination address, the payload itself, end of text, the checksum, and then the fillers again. This looks fairly understandable, but there is a problem with it. The problem could be if the header or the CRC, that is cyclic redundancy check, in themselves contain a communication control character. Is it a problem? Well, it is a problem, but it's not a very serious problem because the header and CRC appear after the start of text, so the frame has already started, and before end of text, so the text is actually going to occur. The end of text is going to occur towards the end of the frame. Apparently, there is no problem. The problem gets serious when the start of text or end of text appear within the payload. For instance, if end of text appears within the payload, it could be considered as an indication that the frame is ending here. For that, the solution is to take care of it whenever it appears in the payload. And the solution is called the transparent mode. Here you see that the transparent mode uses special control character called data link escape, DLE. It's a special control character similar to STX, ETX, and SYN. It is inserted before the STX character to indicate the start of the frame in transparent mode, and also before ETX to mark the end of the frame. If STX or ETX appear within the payload, since the preceding DLE is missing, it would not be considered as a control character to mark the start or end of the frame. If the DLE itself appears within the payload, then an additional DLE is inserted to notify and alert the receiving device that in transparent mode, if you receive two DLEs, it means the DLE is within the payload and the other DLE is intentional. So remove it and process the DLE as part of the payload. Using this mechanism, the problem of two sending and receiving devices getting out of synchronization is resolved.